IIT Bombay is one of the leading research universities in the nation. We have over 13,000 students, over 750 faculty, almost all possible disciplines which you think we can be in the engineering field. And as a part of that, we have a very large manufacturing research centers. And this happens to be one of the hybrid additive manufacturing center where we're standing. In this center, we look at aspects of taking additive to the next level. This is a Meltio additive from Haas, from Phillips Additive. So what we have here is directed energy deposition technology. What it does is that it only adds the material where you want to build. And that gives you multiple advantages. Of course, it saves you cost of putting the powder, filling the entire bed with powder. But the biggest advantage I would say is that it provides you an ability to add material at any angle. A powder bed cannot be tilted. The moment you tilt the powder bed, it will roll out. Whereas in this 5-axis machine, you can tilt the bed and deposit the material in any orientation. Now, this is a huge advantage, but at the same time, it's a big challenge. A challenge because now you have 2 extra degrees of freedom. And that becomes an extremely interesting problem for academics. And that's where our students are performing research on looking at the complex tool paths they can follow for the 5-axis deposition. Now, this is much more challenging than just a powder bed deposition. But with the extra degrees of freedom, you actually have more levers to create materials which are more complex, which otherwise are not possible. Now, to add to that complexity, we also have machining possibility, and that too in 5-axis. So that adds another layer of complexity. And that another layer of complexity is again a great engineering problem, but at the same time, it provides you flexibility on making parts which you otherwise cannot make with the regular powder bed technology. So I think that is one of the key aspects, and this is where most of our research students are working on. So this is the next level where you will be able to have complete degrees of freedom in deposition as well as in machining, and thus you have literally the entire 3-dimensional space to build a material the way you like. The part decomposition, the build orientation, everything can be chosen as you would like. That also really opens up a lot of avenues for parts which otherwise were never thought to be made by additive manufacturing. And that's where we are developing technologies for industries and for many other aspects of space and aerospace components, where we can now really think of making an additively manufactured part on a production basis, not just for prototyping. And that is one of the key advantages I would say this technology has over its competitors. So the 3 key ingredients which I would say are the best part of it. One is it's a DED on a 5-axis. Thus you have no essentially, you have a lot of degrees of freedom. And the third, the most advantage is that you don't have just metal deposition, but you have machining as well. So that really makes it a winning combination. And it really hits the key, performance index, which one may say, like it can build much faster, it is far more efficient, it's higher quality, and it's much cheaper. And as you can see, we can build parts as well as perform machining, get the right surface finish we need. So this essentially takes care of all the shortcomings of what an additive would have. Now, we have been extremely happy with this machine. We have built titanium parts, we have built steel, Inconel, even aluminum. So one of the key aspects I would say, which we are very happy with is the way Phillips Additive and Phillips Machine Tools have been supporting us. From the very beginning, I do remember when we were having delays because of COVID and other aspects, they were very upfront and they came and told us that there are delays of 1 week, 2 weeks, and I was really happy to see how transparent they were. And of course, we worked together, we knew it was a challenging time. And ever since then, there has been a relation which has been building. It's almost no paperwork. I can always pick the phone up and call them if I need anything. And they're very receptive and always there to help. And from the bottom till the top leadership are always looking at us as one of their premier customers whom they want to really be showcasing in all places. And that is reflected in the way they come and help us in putting things together. If we need any kind of assistance, they make up, by sending people here, setting up calls with folks in US and all those aspects. And at any given point of time, we at least every week have a couple of people here physically stationed who are doing things with us. And that really is a huge support, because looking at an educational institution where we don't have continuity of people because students come, they learn, and then they go, that really brings in a lot of stability and continuity. So I think this is a fabulous win-win situation. I'm sure they would be really liking us having such a kind of a diverse utilization of their machine, but at the same time, we really love their service, their responsiveness, and their eagerness to work with us in all aspects, be it research, be it developmental, or be it just simple training. We may have new students who come. We'd like them to be trained again. They have never said no. Whenever we need, they say, "Oh, well, you let us know, we'll come and conduct a training." So I think this has been a fabulous interaction, a fabulous relation. And I really look forward to this growing further in future.